The main thing you need to know about percents is that a percent just represents the number as a fraction out of 100. So 55% means that we have the number 55 out of 100. Okay, so this is what it represents as a fraction. And then because this is out of 100, you could easily convert this to a decimal. So this is equal to 0.55 or 55 hundredths. Okay, so there is a clear relationship between percents, fractions, and decimals. You could always start with any one of these and then convert to either of the other, like a fraction or a decimal. You could start with a fraction and then convert to a percent, or you can convert to a decimal, and then same for decimals. Okay, so let's do some quick basic examples. So 0.28, 28 hundredths, how do we convert that? So this as a fraction is just 28 hundredths. And so because this is written now as a fraction out of 100, then that means, well, what is it as a percent? It's just this number percent, so 28%. Now 5%, what does that represent? That's just that number out of 100, so 5 hundredths. Or you could, as a decimal, write this as 0.05, or just 5 100ths. And 0.02%. This one throws people off a lot because people want to write this as 0.02, but that's not correct. Because remember that this just represents this number as a fraction out of 100. So this is really 0.02 over 100, or 0.0002. So add a couple extra zeros there. Okay. When you're working with percents, it's usually good to have some of the basic percents just sort of at your fingertips. So it's good to sort of be familiar with the fact that 1/2 is 50%. 1/3 is about 33%, or exactly like 33.3 repeating percent, or 33 1/3%. It's good to know multiples of that. So like 2/3 is 66.6 repeating percent, 66 2/3 repeating percent. 1/4 is 25%, 3/4 is 75%, 1/5 is 20%. It's good to know the multiples of that. So 40, 60, 80%. 1/6 is 16.6 repeating percent. 5/6 is 83.3 repeating percent. And 1/10, of course, 10%, all your multiples of that. And then 1/20th is half of that, or half of 10%, so 5%. So having these all at your fingertips just makes computations a lot easier. So for example, you have something that costs $80 and it's maybe on sale for 24% off. Then how much is that going to end up costing? You could say, well, this is pretty close to 25%. 25% is 1/4, so this is like 1/4 off. 1/4 of 80 is 20, so it's like about $20 off, a little bit less than that really. So it's going to be like about $60, maybe a little bit more. Okay. Here's a problem. The cost of a $15 cake goes up by 10%. Then the cake goes on sale for 10% off. Pause the video and think to yourself whether the final sale price of the cake is going to be equal to $15, a little bit more than $15, or a little bit less than $15. Okay, so pause the video right now and make a guess for yourself whether it's going to be more, less, or equal to the original price. All right, so let's go through our answers. So starts at $15, and then we go up by 10%. 10% of what? 10% of the original price of $15. So 10% of $15 is 0.10 times 15. So that's $1.5 or $1.50. So we end up at 15 plus $1.50, so $16.50. And then what happens next? Then it goes on sale for 10% off. So 10% off of the new price, which is $16.50. So it's going to go down by 10% of $16.50. And so this is the key right here, is that over here it went up by 10% of $15, and here it's going down by 10% of $16.50. So like the new price. So this is getting back to like the whole thing with like, what does the whole represent with fractions? So if you're not paying attention to what the whole represents for your fractions, then you're gonna set yourself up to get confused a little bit. So over here, these percents are still fractions. They're fractions out of 100, right? And they these 10%, even though they look the same, they're fundamentally different because this is 10% of something different than this 10% is of. So their wholes are different. Okay, so when we go down by 10% of 1650, we're going down by 0.10 times 1650, or 1.65. So $1.65. So we go down by $1.65, and we end up at 1650 minus 1.65, so that is equal to $14.85. So our final answer is a little bit less than $15. All right, let's do another problem. Bottle of soda is on sale for 20% off. The soda now costs $2.40. What was the original cost? So here's a good place to use a variable. So let's say that x is the original cost. So we start at X dollars, and then we go on sale for 20% off. So we start at X, and then we subtract 20% of X. So if we're subtracting 20% of X, then that means we subtract 0.20 times X. And then we end up with $2.40. Okay. So this over here is equal to 0.8 or 0.80x. That's equal to 240. Now over here, it's good to think of this as a fraction whenever possible. So 80%, so 0.80, that's the same as 80%, and that should make sense too, because if this is going on sale for 20% off, then that means our new cost, $2.40, is 80% of the original. So this is 80% of X, which is 0.80x. Okay, and if you want to think of this as a fraction, then this is equal to 4/5 of X, which is 240, and you could multiply the reciprocals or whatever, so 5/4 times 5/4 or whatever. So this is always going to kind of get you there. Or you could just notice like, oh, hey, 80 goes into 240 3 times. So so just divide by 80 on both sides. And so this over here is equal to 3. So $3. So our original cost is $3. All right, so again, there's a lot of different ways to sort of think about a problem like this. So in this case, it just kind of happened to be the case that like the numbers worked out nicely, that you could just divide by 0.80 because 0.8 goes into 2.4 three times. But if you can't really see that very easily, then converting this to a fraction might actually make your problem a little bit easier. And so being able to flip between decimals and fractions and percents sort of at will is just going to give you more options when you're solving problems, so that because you never really know which of these options is going to be the most efficient way to get you to an answer, and always the most efficient way is, you know, in a sense, the best way to get there. So anyway, that's all. Thank you.